Java's reflection package, java.lang.reflect, gives your code the ability to find classes that describe the code itself. Objects of the class java.lang.class describe the code of the classes in your system, so your code can reflect about what your code is made of. And that's pretty trippy, and a pretty powerful tool when you need it. To give some context for why this is cool, think about these challenges. You have a wide inheritance hierarchy, and someone who is using polymorphism needs to do something special for one class. Yes, you could, and maybe more correctly, fix this by adding a method to the hierarchy. But often in real life, you don't own the code to the hierarchy. In that case, being able to ask an object what class it belongs to can be very useful. You have a set of operations that all implement one interface, and you'd like to create a sequence of them on the fly, and the order of that sequence needs to be configurable by the user. You could have a text file that contains the names of the objects in order, and then your code could use the names of the classes to create the objects at runtime. You have an object that was given to you by an API that you can't control, and you can see in a debugger that has a variable holding the information you need. You can use reflection to get all of its instance variables, as long as they aren't private, and then you can see what you need. So reflection gives us access to the code of the system, and we can leverage that to solve a wide variety of problems. None of the classes in java.lang.reflect have public constructors. Everything starts by finding the java.lang.class object for the thing you want to learn about. We can do this 3 ways. First, if you have an object, you can use its getClass method. That returns a class object that describes the code of the class that the original object belongs to. If I run this, you can see that this is a sequence of the class objects it gathers. One thing to note, class can be given a generic, which narrows the type of class objects that it can reference. For this one, I made it be only able to reference classes which extend string, which will include the class string itself. Second, for both reference and primitive types, you can ask the type for its class. So, I can ask the class string for its class objects, and I can do that for an enum. And even though primitive types don't feel like classes, you can do it for primitive types too, even void. We can also get the class object for an array. In this case, the name of the class object is going to have one opening bracket for each dimension of the array, and then a type like this. So a one-dimensional array of integers has a class object that will be named square brackets, capital I. A two-dimensional array of strings will have a class object named square bracket, L, java.lang.string. The bigger point here isn't how they're named. The bigger point is that we can get an object that describes the code related to primitives and arrays, even though they don't feel like objects. The third way we can get the class object is from the name of the class, and this has great power. To do this, we use the class.forName static method in the class. We just pass in the name of the class, and it returns a class object representing that class's code. So my class will reflect the code in the class myClass. If the class you're interested in resides in a package, you have to include the full path. So for example, string is in java.lang.string. Class.forName will throw a class-not-found exception if there's no class with the given name. So you either have to have a try-catch block, or you need to add a throws to your method declaration. Once we have a class object, we can do all kinds of things with it. We can ask it things like, what methods do you have? And then we can invoke those methods. What instance variables do you have? And we can change their values. What class do you extend? What interfaces do you implement? And so on. Let's play with a few of those. Once we have a class object, one thing we might want to do is use it to create new objects of that type. To do that, we need a constructor. For demonstration purposes, I made my stupid class have 2 constructors. The first is a no-arg constructor that sets the instance variable no-arg to true, so that we'll know that the no-arg constructor was called, and defaults data to value 2 and question to life, the universe, and everything. The second constructor has parameters for both data and question, and sets no-arg to false, so that we know that the object was not created with the no-arg constructor. I can get the no-arg constructor by calling getConstructor with no arguments. That gives me an instance of the constructor class, which has a generic that specifies what kinds of objects it's related to. Once I have that object, I can use it to create an instance of my class using the noInstance method. When I run this, you see that noObject has no-arg as true, and data defaulted to 42, and question as the life, the universe, and everything. So we definitely use the no-arg constructor to create it. I needed a catch block to catch a few exceptions that can occur with this sequence of calls. No such method exception can be thrown by getConstructor if there is no public no-arg constructor. Invocation target exception if the constructor that we invoked threw an exception itself. Instantiation exception if the class is abstract and therefore we cannot create an object from it. And illegal access exception if the constructor is not visible due to its access control modifiers. In addition to the no-arg constructor, I can get a particular constructor by passing the classes of the types of the arguments I want into the getConstructor method. For example, to get the to-arg constructor that has int and string parameters, I call getConstructor passing in int.class and string.class, which is really java.lang.string since that's where I imported it from. Once I have that, I can create the object by calling noInstance and passing in the arguments, in this case 16 and not now. The object that gets created has no-arg equal to false, because we didn't use the no-arg constructor, and data has been set to 16 and sentence has been set to not now. Once we have that class object, we can ask it for lots of things. For example, we can use getDeclared method to get a method object describing the code for a given method. Once I have that object, I can print it out, and I can use its invoke method to actually run that piece of code. While this seems like a really, really silly thing to do, but watch this magic. I can make an assembler pretty easily with this. My assembler has 1 register, and the assembler's commands do mathematical operations on that register. I'm going to start by having my assembler class have a method for each one of those operations, and the rule is that the method has to have the same name as the operation. In addition, each one of those methods has to have the same parameter list. So even the print method that doesn't need a parameter gets one. That's going to let the magic happen. With that infrastructure, my assembler just needs a loop that processes 1 line of code at a time. After I separate the instruction from the argument, I need to figure out which method to call for this instruction. I could have a big if statement or a switch block, but reflection gives me another option. I can use reflection to find the method whose name matches the instruction we're trying to execute. So cool! That gives me a method object describing the code that we need. Then I can call the method object's invoke method, passing in the object I want to do the method on and the parameters to call that method. So if the instruction was add, M is an object that describes this code, and the call on invoke is equivalent to calling the add method on my assembler object. That's a pretty slick alternative to a long set of conditionals. One warning. Sometimes I get careless when I'm doing this, and I call getMethod instead of getDeclared method. GetMethod will only give me public methods, while getDeclared method gives me public, package, and package private methods. So if you're trying to get a method that you know is there, but reflection can't find it, Check to make sure that you're using getDeclared method if it isn't public. And no, you can't get private methods this way. That would be a huge security issue. I hope these examples give you an idea of what you can do with reflection. There are lots more powerful reflection tools. I need to make more videos about this.